So last time we talked a little bit about how to find the limits continuity and how to solve some of the well-known easy limits that other scientists already solved for us that we can plug in directly either in the exam or whenever we have that problem in our real life situations. Today we will talk about how to find the limits in a basic initial way using tables and tracing graphs. So let's say you have a table that represents how the limit is approaching a certain value from the left and from the right. So you have the table here, you have the values of x down here in this column, and you have the values of f of x or y in this column. Now you don't know where this limit is approaching. So the limit of x approaching f of x, we don't know what is the x that we're approaching, and we don't know the f of x. The x we can define, like let's say in this case we say let the limit as x approaches to 4, which means x approaches to 4 from the right and from the left, equals f of x. If we want to find what's that f of x as we approaches to 4, then we can plug in values of x as x equal to f of x equals 7, x equal 3.6, 3.9, 3.99. Obviously you're approaching x from the left in this exact case. Then you have 4.001, 4.1, 4.85. Then you're approaching, as you're going from 5 all the way to 4, you're approaching the x value from the right. So this is how you know. Imagine this table as it's been laid horizontally, then you can tell if you're approaching from the left or from the right, as you can see from these arrows. Now if we say we're approaching to 4 from the left and the right, then what would be the limit of f of x as x approaches to 4, assuming f of x as a rational function? So in this case the value of f of x would be 11. You are approaching 11 value from the left and from the right as you're approaching the x value from the left and from the right. For the graph, let's say you have already what is this f of x. Let's say it is 2x plus 3. Then you can draw that graph on the Cartesian xy axis. Then you can approach number 4 from the left and from the right. As we learned before, you can see we are approaching f of x or the y. That is the value of 11 on the y-axis. Now if we have a function f of x equal 3x minus 1. Now we have the x values and f of x. We want to generate our table as x equal 5. We have f of x 14. X equals 5.9, 5.99, almost 6, 5.999. That is approaching number 6 from the left. And we have the value 6.1, 6.47 approaching the 6 value from the right. That will lead you to which value? We want to know what is the limit or what is the value of f of x as we approach x from the left and from the right. So the limit can be said, the limit of x as x approaches to 6 from the right. So we see here going from 7 all the way to 6. If you imagine the x-axis and how the values are laid over on the x-axis, you know that you're approaching from the right to the 6 by plugging in those values. Then in this case, what is the f of x? So the limit of f of x as x approaches to 6 from the right. So you can see here we reach almost to 17. So we go from 20 almost 17. Then when we go from the left, you go 16.99. So we jumped over the 17. So this value must be, roughly saying, must be 17. Then if you take the limit as x approaches to 6 from the left for f of x, that should be 17 as well, because you're approaching to 17. Then you jump above 17 and go 17.003. So that value must be 17. In this case, you can generalize that the limit as the limit from the right and the left as x approaches to 6 equals 17, then the limit of f of x as x approaches to 6 is surely 17. You can as well, as we said, rational functions, you can go to solve that limit of f of x, you already know this f of x over here. So you can plug in the 6 instead of x. 3 by 6 is 18 minus 1, that's 17. So you're good to go. Now let's take an example. You have f of x, a little bit more moderate kind of progress in solution. F of x equal, in this case having denominator and denominator, x squared minus 1 over x minus 1. In this case, he's asking you, what is the f of 1? No limits, nothing. Take the 1, plug it in instead of the x's over here, and you will get your value. So in this case, 1 squared is 1 minus 1, that equals 0, over 1 minus 1 is 0. In this case, we're having a solution of 0 over 0. That's an undefined solution. So in this case, you can say f of 1 does not exist. So see the solution here? Have 0 over 0. That means f of 1 does not exist. So there is no point on the graph of f of x that is shown below for the x equal 1. That's what does that mean. If you look at the graph, if we graph the x squared minus 1 over x minus 1, you can see that linear line on the Cartesian, but you have at f of 1, which is the value of x equal to 1, wherever that value intersect on the curve of that function, then we have a disconnected point over there. That means that point, or that point on the function, is undefined point, or there is no point on the graph of f of x that represent x equal 1. So if we want to look at that through a table format, as x approaches to 1 from the left, which means exactly x less than 1 in value, then you have your f of x. So at 0.9 we have, this is f of x. At 0.99, at 0.999, we have the f of x as 1.999. X approaches to 1 from the left, that's the one. We are approaching the 1 from the left as following the graph, and you're getting your values approaching to 1. So that's what you got as f of x. You're almost approaching to number 2. As x approaches to 1 from the right, or x bigger than 1 in value, what is the f of x? So we're approaching from the right to the value of 1 at the linear graph of f of x. So at 1.1 we have 2.1. At 1.01 we have 2.01. At 1.001 we have f of x as 2.001. In this case we're approaching to 2, obviously. So branch B of the example 1 saying, what is the limit of f of x as x approaches to 1? So we have the rational function. So we have the function f of 1 is undefined or does not exist in this case. So what is the limit of f of x as x approaches to 1? Like limit as x approaches to 1 of f of x, or of x squared minus 1 over x minus 1. You can see as we approach to 1 from the left and to 1 from the right, we are getting the value of 2. So even though the function does not exist at x equal 1, still we can get the limit at x equal 1, which is approaching to 2. Now we have a function h, g of x, f of x, h of x, all the same. So you have h of x equal 2x plus 2 for x less than 1, or as we are approaching 1 from the left. This is what you can understand. And we have h of x equal this function 2x minus 4 as x equal or higher than 1. So now we need to find what's the limit of the function h of x as x approaches to 1, and what is the limit of h of x as x approaches to minus 3. So to find the limit, we need to approach 1 from the right and from the left. So if you approach 1, let's assume we draw the graph here representing 2x plus 2 and 2x minus 4. As x approaches to 1 from the left, you're approaching to 1 from the left, then you are approaching on the y-axis to number 4. So the limit of h of x as x approaches to 1 from the left equal 4. That's what does it mean. Now if we approach the x from the right, as you approach limit of x approaching to 1 from the right, that's where the 1, you approach the 1 from the right, then the limit equal -2 because you are heading towards this value. And that's how numerically how does the table look like. You can see the values for -1 or for x approaches to 1 from the left and x approaches to 1 from the right. They are different and varying. So you can see the limit for 1 from the left and the limit for 1 from the right does not equal each other. As long as the limit as x approaches to 1 from the left does not equal the limit as x approaches from the right. If you remember the testing the existence of a limit, in this case the limit does not exist. Now if we solve the part B of the question, limit of h of x as x approaches to -3. We want to approach -3 from the left and from the right to be able to tell what is the solution for that limit. If you draw the graphs on the xy axis, this is how it look like. As we mentioned, approach -3 from the left. As you approach -3 from the left, you are heading to -4 for the f of x. So as you are approaching -3 from the right, you are heading towards a -4 as well. You can imagine we looked at one graph only, we ignored this one, because if you look back in the function, if your x is -3, that means x less than 1, then we care about this equation only. So that's the trick of this kind of format of questioning. If you have x equal -3, then you care about this function only, as if this one does not exist at this case. While if you give you 3, 4, 5, anything larger than 1, then you ignore that. Anything less than 1, you ignore that function and you stick to this one. But if he gave you the limit at 1, then you care about both of the equations in this case. So you can see limit h of x as x approaches to -3 equal -4. The limit in this case exists and equal to value of -4 versus part A of the question where we found the limit does not exist.